Hello everyone. I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about open loop control systems. This is linear control systems and lecture series on linear control systems. Lecture number 3. So our new topics open loop control systems. So what is open loop control systems? Why open loop control systems? Advantage of open loop control systems, disadvantage of open loop control systems. This is our main target. So what is the overview? What is open loop control systems? Basic block diagram representation of open loop control systems. Working loop of open loop control systems. Advantage of open loop control systems. Disadvantage of open loop control systems. Examples of open loop control systems and comparison between open loop and closed loop control systems. This is our overview. Then what is open loop control systems? Open loop means no feedback path. So the control technique in which the calculated or estimated amount of energy is supplied to a process plant according to the practical experience of an operator in order to maintain a process variable at the desired value without receiving any feedback information about the actual value of the variable in the process plant. This is called open loop control systems. So open loop control systems, no feedback information, and this is controlled by experience operator. This is controlled by experience operator, of an experience operator. And what is the example of an open loop control systems? Suppose room temperature. Control of temperature in a room by adjusting coal or fuel flow to the furnace of the steam generation by an experience operator. So room temperature control, example of the open loop control systems. Then block diagram for open loop control systems. First, coal supplied by the experienced operator according to deviation of room temperature from desired value. So first case, coal supplied by an experienced operator. This is the main point. And what is the amount? Room temperature from the desired value. From the desired value. This is the main point. This and this two main point. And next, coal burn in the furnace. So next point, furnace or heating systems. Coal burn and boil the boiler water. And this boiler water control the water tank. And this boiler produce the steam, and this steam storage, the steam storage unit, and this steam control the room temperature. This is our target for open loop control system. So this is our room and room being heated. But if our required temperature 25 degrees centigrade, but after controlling, if less than 25 degrees centigrade and if greater than 25 degrees centigrade, this temperature not informed by output to input section. That's why this type of control system is called open loop control systems, because there are no feedback information output to input, and extra gas and or outlet. This is the exhaust systems. This is the exhaust system. So this is the open loop control systems. Example, room temperature. Then another definition, open loop control systems. In open loop control systems, the plant output is not feedback to the input. So an open loop control system is one in which the control action is independent of the desired output. So this is our second definition for open loop control systems. In this case, no feedback FWD feedback to the input, and this is the general block diagram or simple block diagram for open loop control systems. This is the input signal, and this input signal may be step, ramp, parabolic impulse, sinusoidal, any type of input you can apply it. And this is the controller section. Controller section control the input signal, and controller output signal is called actuating signal, and actuating signal actually input of the plant signal. So this signal very important because this signal control the plant action or process action, and after operation, this is the controlled output signals. This is the controlled output signal. In this case, no feedback information output to input. That's why this type of control system is called open loop control systems. This is the block diagram of open loop control systems. And another definition in this type of control system is one in which the plant output is dependent on input, but the controlling action or reference input is totally independent of the output. So this is also very important for open loop control systems definition. In this type of control system is one in which the plant output is dependent on input, but the controlling action or reference input is totally independent of the output. So this is also simple block diagram for open loop control systems. This is the input signal or set point or reference input. This is also called RT, R of T. And this is the controller section. Controller section control this signal, and the output signal is called actuating signal. This is also called U of T in control system language. This is the plant or process after operation, plant or process output. This is the control output. This output is called CT. This output is called C of T. So the block diagram of the open loop control systems. Then important features of open loop control systems. What is the important features of open loop control systems? Working loop of open loop control systems. For a specified input, the open loop system produce a definite output. This is the very important sentence. For any disturbance, the plant output changes, but there is no adjustment device of the input side, so the original output be different. This is also very important sentence. So this is the block diagram for open loop control systems. And next point, open loop control systems. In open loop control systems, there is no assessment between actual and desired value. There is no assessment between actual and desired value. This is also very important sentence, important features. In open loop control system, no self-regulation or control action over the output response. For the controller in open loop control systems, every input position resolves a fixed operating position. Their ability to perform accurately is determined by their calibration. This is also important features. Advantage of the open loop control systems. What is the advantage? Open loop control systems are very simple in construction and design. Construction and design are very simple. Open loop control systems are economical. The open loop control systems are easy or less from maintenance point of view. Open loop control system generally stable or there is no stability problem. Open loop control systems are suitable to use when output is complicated to measure. Proper calibration is not a problem. These control systems are suitable to use for output calculation. These are all advantages. And what is the disadvantage of open loop control systems? Open loop control systems are inaccurate in nature. Open loop control systems are not reliable. This is the second disadvantage. Open loop control systems are not reliable. The open loop control systems are slow. Open loop control systems optimization is not possible. Open loop control systems are not accurate and reliable because their calibration is not proper. This is also a very important sentence. Open loop control system gives the incorrect result for a parameter variation. For maintaining superiority and accuracy, recyclation of the controller is required from time to time. This is also very important sentence. It cannot correct the output deviations automatically. The bandwidth of open loop control system is less. So example of open loop control systems. Next point, example of the open loop control systems. The examples of the open loop control systems are automatic washing machine, a field control DC machine, time-based bread toaster, electric hand dryer, automatic milk server, immersion rod, automatic coffee server, and electric lift, traffic signals, spark light, and also electric bulb. Volume of the audio systems. We can adjust or regulate the volume of an audio system by manually. Water, weather, facts, TV remote control, sets or building on a windows, stepper motor or servo motor, inject printers, door lock systems. Real-time examples of the open loop systems. Real-time example, electrical cloth dryer and mobile cellular phones, word processor. These are real-time example open loop control systems. Examples of man walking on a road. This is the open loop control system, man walking on a road. What is the principle? When a man walking on a road with his eye closed, this is the open loop examples. When his eyes closed, this is the open loop example. But when open the eyes, this is closed loop examples. So next point, the major components involved in time of walking are number 1 brain, number 2 eyes, and number 3 head. So input, what is the input? As the desired walk distance. And what is the output? Is actual walking distance. And what is the control action? Is determined by the eye. Is determined by the eye, which detect the difference between the input and output. That means as the desired walk distance and is actual walking distance, and send the information to the brain. The brain command the leg and feet to walk in the given direction. Walking is a closed loop operation because the control action is a function of the output. So this is the very important sentence. Walking is a closed loop operation because the control action is a function of the output. Then if the eyes are closed, the feedback loop is broken. So when eye is closed, eyes are closed, the feedback loop is broken. The feedback loop is broken and the system becomes the open loop. So what condition this will be closed loop? When the eyes open, and if the eyes are closed, the feedback loop is broken and the system becomes open loop. This is called open loop systems. And next point, those the man walking on a road with his eyes open from a closed loop control systems. And if anybody moves away from the desired road with open eyes, it is an example of the closed loop control systems, and it will be an open loop system if eyes are closed. So this is the open loop systems, and fast case closed loop systems. And this is the block diagram for open loop and closed loop systems. This is input, desired direction, and this is the eyes. This is a comparator, or this is the summing point. This is the eye, and this signal control the input and the feedback outputs. So this output actual input of the brain, and this is the controller of the systems, and the brain instruct, and this is the signal, and this signal control the plant or process, and this is for this case legs, and this is the output. What is the output? Actual direction. This is the actual direction. If this is the, if eyes are open, then this is closed loop systems, and if eye close, then this path not present, and then this is the open loop example. So this is the control systems for open loop examples. Another examples, electric cloth dryer. What is the block diagram? This is the block diagram for electric cloth dryer. Desired time, set the desired time, and this is the electrical energy supply. This is timer or controller section, and this is the heating element or output, and generates a signal, and this signal control the process or plant. So in this case, this is the cloths. And what is the output? This is the actual dryness. After actual dryness, this is the actual output. Suppose set a time, say 30 minutes, the machine stops working automatically after 30 minutes. So this is the second example for electrical cloth dryer. Then open loop and closed loop control systems. Difference. What is the difference? Open loop control systems and closed loop control systems. First point, feedback path is not present. For open loop control system, feedback path is not present. For closed loop control systems, feedback path is present. For open loop control systems are not reliable. Closed loop control systems are reliable. Control action is independent of the desired output for open loop. For closed loop, control action is dependent of the desired output. And for open loop, these are also called as non-feedback control systems. These are also called as feedback control systems. It is easier to design or build. For closed loop control systems, it is difficult to design or build. For open loop control systems, these are less economical, and for closed loop control systems, these are more economical. If calibration is good, the performance accurately. For open loop control systems and for closed loop control systems, the performance accurately because of the feedback. Another difference for open loop and closed loop systems, open loop control systems are generally more stable, and closed loop control systems are generally less stable. Open loop control system optimization is not possible, and for closed loop control systems optimization is possible. The open loop system is simple to construct and cheap. The closed loop systems or control system is complicated to construct and costly. The operation of open loop system is affected due to the presence of nonlinearities in its elements, and the operation of closed loop system is adjust to the effects of nonlinearities presence in its elements. The open loop control systems signify the simplest from the controlling device. The closed loop control systems not signify the simplest form of controlling device. These are all open loop difference between open loop and closed loop control systems. So this is our open loop control systems basic idea. So thank you.